All right. So, hey everyone, to the third session of Permissionless Learning. Today we are going to talk about space tech, and we have Madhavi Swami with us, who is a learner of space tech and who is working and has worked with a few startups in space technology, particularly in India. So, before we get started, I would like to talk a little bit about what permissionless learning is. So, I think most of you might already be aware of what that is, but just to give a brief idea, permissionless learning is about the idea that you can get started with learning something or building a product or something else by yourself without waiting for permission from a university to tell you that you're qualified to learn something, or waiting for an employer to tell you before you start building your own startup or any project that you want to be working on. So, today we have Madhavi Swami, who is a learner of space tech and also who has started building a few of her own things in space technology without having to wait for a permission from a university or an employer to do so. And before we get started, I would also ask you to follow the permissionless learning channel here so that whenever we are hosting any sessions in the future, you get a notification in your Clubhouse app directly. So, uh, Madhavi, would you like to get started and tell us a bit about the uh, fundamentals of space technology, or what space technology is all about?
Right. So let me tell you about this amazing thing that's happening tomorrow. Richard Branson, the CEO of Virgin Galactic, along with five other team members, is flying to the edge of space. So the spacecraft that they are using is called Spacecraft 2, and the most brilliant thing about it is that it won't be launched like any other conventional spacecraft. It is going to be launched in the space, so it won't be a ground launch. There's a spacecraft that will carry there's an aircraft that will carry the spacecraft at a particular altitude from which it would be launched. So this is about space tech. This is something fascinating about what this technology is bringing. The first mission was the space race started in 1955 or 1957, I think. And look where we have come. uh, it's a fascinating technology, fascinating field. Yeah, that's about it.
Right, right. And can you give a brief about, you talked about like Virgin Galactic being a part of the space, of the modern space race, where instead of, individual countries trying to achieve their own goals, now it's a bit more of a collaborative environment. And even Indian companies are a part of it and trying to launch their own space vehicles or being a part of international missions. So do you want to talk about what the current scenario is globally and in India?
Yes, sure. So there were limitations with the national space agencies of all countries. So may it be funding, or may it be the employees, or the technical front. So they thought of collaborating with the private companies. And private companies, when they entered this market, they entered with a vision of bringing in space tourism into the table. So that how it started. It started with an idea that space should be accessible to all, and that's how the private giants are leading the market. So tomorrow's the launch of uh, tomorrow's the launch of Spaceship 2, and after 8 days, it's going to be Jeff Bezos and two other fellows who would be going into space. So both the missions are very different, but they are changing the scenario of space technology in India. the Blue Origin is the team of Blue Origin is going beyond the Earth's atmosphere. They are going into the outer space. Tomorrow's launch would be till up till the edge of space. They won't go beyond the Kármán line, which it's a hypothetical line that differentiates Earth's atmosphere and the outer space. So
Okay.
yeah, that's how the private industry is leading the space technology market.
Okay, so what are the opportunities for people within us, within who are like a part of the audience or even the general public to be a part of this space technology race?
So yeah, yes. So unlike any other corporation, space industry needs people from various backgrounds. We have engineers, we have data scientists, we have people with highly amazing business skills to see to it that the business goes. There's funding coming in, and there's exchange of technology transfer. There's operation people running the operational front. There are people into the commerce side, like accounts and I'm not sure of what else, but that's what I could come up with. uh, there are also yeah, so these are the aspects of this field. We need people to see to we need people to build the propulsion engines, we need people to design the aircraft, we need people who could plan the mission strategies. We have people who are into space and aviation law, who could yeah, people who are lawyers but into the space and aviation field. There are people who are studying medicine but are also into the space tech market
Right,
to
right. Uh,
ensure the biological aspects of what happens when people go into space, what are the uh, factors that determine the sustainability of life on other planets,
right.
something like that.
Right. So, can you, for more interest, can you go into one of those topics? So, I think we have a lot of, for example, software engineers among us, and they would be interested in knowing how software engineers can help in space tech because there's the obvious ways with building user interfaces for the people who would be within the aircraft and within people who would be on the ground control. But what are some non-obvious cases that you can share with us for example, for software engineers, which would be interesting to us?
So a lot of these spacecrafts are autonomous. They are fully autonomous. Uh, they function on their own. They take decisions on their own. So the brain that they have is built by uh, people from computer science background, right?
Right.
Uh, Apart from that, there are several, I think, interfaces like you mentioned, where also coding is required. So one module connecting or communicating with another module, there has to be some kind of communication. So that is also handled by computer scientists. um, Also the
So
communications that happened between people from who work on the ground, in the ground zones, and with the spacecraft.
right. So I was going to ask you about so you mentioned about spacecrafts being autonomous. So that's quite interesting. So can you, I mean, if you are aware of it, can you give us a brief into what kind of technologies go into building this autonomy into spacecrafts?
Um, I'm not sure. Uh, can you frame it a little more
Right. So, I mean,
sim- can you simplify the question?
yeah, so I mean, how do the space tech engineers build that autonomy? Basically, like what goes behind it, if you are aware of the details. I mean, of course, I mean, in depth, you might not have in-depth knowledge about the computer science part of it, but still, I'm just curious to know more about it.
Uh, I'm assuming that the technology that is used in building autonomous robots is the same technology that is used to build autonomous spacecrafts.
Okay.
So yeah.
Okay. Uh, you talked about a few of the opportunities on the tech and non-tech side. How, if someone wants to apply for those opportunities or go there, like, how can they learn? So, to know about that, I think it would be helpful to learn about how you learned about space tech yourself and what were the challenges that you faced yourself while you were learning about space tech.
Yes, so for me, I was interested into materials, and I was rather interested into materials that were being used in space or that are sustainable in the outer space environment. So for that, I started with basically, uh, I started reviewing the fundamentals of the subject itself. I
O-
started with reading books that were listed on my uh, institution's website, those which were recommended by our professors. I started with those. These resources are the very basic ones. So while reading those and learning those concepts, I also used to search on the internet. Where is it used now? I mean, where is that particular concept or that particular product used right
Right.
now?
So you were
If
going for a
not,
more of a application-oriented view while learning new technologies. I mean,
yes,
while learning
exactly.
new concepts, I guess.
Yes, exactly. So my basic idea was that what was the fundamentals? Why are they not? What are the limitations? Why are they not being used right now? And those? What are the replacements that are being used in the modern technology? So that's how I would connect the dots, and it would help me understand that concept or that thing more efficiently.
So to make it more interesting, what was a concept that you learned about, and what were some of the applications that you saw, some interesting applications for that concept that you saw online?
Yes, so I was briefly reading about what composites are back in, I guess, when I was in third year, and yeah, so not much was discussed into the college syllabus. So I went on the internet. I first had a look on what kind of composites are being used. Uh, how are they useful to us? There's this thing called as carbon matrix composites. So carbon is one of the most strong material that could be used as fibers. That was something that I learned, and it's still being used in many other applications. But this was particularly used, these CMCs were particularly used to design the airfoils of the aircraft engine. So uh, the article that I read was of Airbus, and Airbus is using CMCs to develop their
Sorry, can you
airfoils.
repeat what
That
CMCs are again?
Hello.
Hello, yeah, can you repeat what CMCs are again?
So they are carbon matrix composites. So the reinforcement is of any polymer, and the basic fibers that it's equivalent to the fibers that are used in construction, right? So there are fibers that are used to develop a building, and reinforcements are put like cement, for example. So that's
Right.
how these composites work. there's
Basically,
there's a material.
you're meaning to say that this is done for reinforcing the strength of the underlying
Yeah,
component.
yeah, right. So that was something that is being used to develop the airfoils, the blades of the aircraft engine.
Okay,
And
interesting.
also, so the thing about composites that I learned was is they are a very good heat shielders. They insulate the aircraft, and basically the application was where the temperatures and pressures were very high. So that means it uh, the temperature is high, so the material is supposed to not get decay. And yeah.
Right. I think there are a few materials like Teflon which are actually meant to burn away when a spacecraft re-enters Earth's atmosphere, right? This is so that instead of burning away at the spacecraft's actual material, it instead burns away the composite which was used to reinforce it, if I'm not.
Yeah, that was actually yeah, that is an application, but due to some environmental factors, uh, i I think it is not actively used anymore.
Okay. And something I think we had talked about during our rehearsal, but I think this point wasn't brought up now. But you talked about taking active notes during learning. So could you talk a little bit about that? Because I mean, note taking is something that we are forced to do during our college days and our school days. But that kind of note taking isn't real note taking because it doesn't actually teach us what kind of notes we should take. Because people who preach about productivity, they generally have a different kind of note taking. So can you talk a bit about I mean, actual note taking, not the school level note taking, and how that helps when you're trying to learn a new concept?
Yes, so I mean, the basic thing is to understand the concept, write down what you understand. It helps at the end, but you should do this. Go with the flow. Go with this flow. I mean, understand what the concept is. Uh, Try to reiterate those definitions or the concept in your own words. That helps you to better understand it. Uh, and then the further on, you have to implement what you learn. So that's the later part, but for the purpose of note taking, you should always write down what you understand and not what the book or the teacher is teaching you.
All
And
right.
that also helps you to that helps in active recalling afterwards when you want to when you want to apply that concept.
Right. By active recall, you mean actively remembering what you had learned previously, I guess.
Yes, exactly.
Yeah, and I think what you mentioned for later, basically how you can apply those concepts. I think that's the more interesting part in this. So can you talk a bit more about that?
Yes, so there are many ways in which you can implement what you learn. First is to, maybe publish the notes. Uh, the second thing is to always write a review article on it or review paper, any academic paper. So that helps you to apply the concepts and learn what is going on around. I mean, you'd not just learn a concept and, you know, uh, wait for it to be uh, wait for your brain to grasp it and stay there forever. You have to keep on reiterating it so that you actually know it. What's the limitations? How was it actually advanced? Why was it used? Everything like that. So implementing a certain concept, maybe not concept, but a bunch of concepts, you can always implement such subjects and
Right,
try to
right.
build
So
something out of
uh,
it.
it's obviously not possible to do this for every concept, right? So what do I mean? What's the level of importance that a concept needs to have so that you actually go through all of the steps that you just described? Because if we, I mean, for example, in computer science, there would be a lot of terms that you come across, and you wouldn't really want to write review articles or publish notes for each of them, right? So, what do you recommend is the set of steps for uh, knowing when a concept is actually important for us to know, learn, I guess.
Uh, uh, First of all, it should be of interest to you. If it's interesting to you, you can pursue the implementation. If uh, or else you can always do research, on the concepts. I mean, is it used anymore? Is it of greater importance? If it is widely being used, and this is something without which the industry would not survive, then you should definitely go for it.
Okay, in the case of space tech, can you talk about any such technologies which you went through, I mean, which would be considered as very important and without which the industry cannot go forward, I guess.
Um, for it, I would get, I would, I think I would go for solid. So let us consider propulsion systems. Any propulsion system.
Can
So
you also
without the
explain any terms which you are saying, because it might be possible that people have are hearing those terms for the first time.
hello, can you repeat?
Yeah, so can you also explain any terms that you're like any complex terms that you would be speaking, because many of the people here would be hearing those terms for the first time.
Yes, right. I'll do that. So the propulsion system is the combustion system of any aircraft. Uh, you would know the combustion with respect to any automobile, the engines.
Right,
So equivalent to that is a propulsion system. So uh, there are types of propulsion systems. It's not only always liquid, it's also solid propellants, and it's also there's also a thing called as ion propulsion that uh, makes use of the fission reactions. So uh, maybe I would say, if I want to study propulsion, if I'm studying this subject and I come across solid propellants which are not being used right now, so I would research on why is it not, what it is, why is it not being used now, and I would come across some limitations that people would generally would not know about, because it's not being used, right? So
right.
it's not in the syllabus if it's not being used. So I would rather pick a topic that would teach me more on the subject than a topic that is widely, which is conventional. I mean, I would go for unconventional topics and subjects.
Okay, okay. Finally, I guess this would be an audience question also, but I guess I would first want Madhavi's take on it. But that's about what are some of the unconventional applications of space technology that we see in day-to-day lives? Uh, so we know, I mean, some day-to-day technologies that we use, like helmets or seat belts, or I think even office chairs are things which originally originated from within space technology. So you, of course, have a more in-depth knowledge about this than me. So would you like to share some of these unconventional uh, like applications which came out of space technology?
Yes, so the biggest example would be the geospatial technology. Uh, uh, the satellites that we sent out in space are used to study, they're used into communications as well. I mean, uh, your Google Maps would not work if it wasn't the satellite running in the space. So just like that, you can map the geology of Earth with the help of satellites, with the help of scanning technologies. So uh, that is currently used by agricultural department to study the soil, to study the geology more in a more efficient manner. It is also used. It is widely used by the defense force, I would say, to mark down, maybe where the terrorists are, to get their location, if there's any trespassing near the border or something like that. So it
Right,
is of a great importance, but we do not get to know about it because it's not these set of informations aren't actually accessible to all. So
right,
yeah.
right. So about like what you said about geospatial locations, or even satellite imaging, which I think is a part of knowing whether there are any trespassers in your area. So I think this is most people are quite familiar with this because of its usage in fictional media. And even when I think Osama bin Laden was caught, there was a lot of satellite imaging involved there. So yeah, that was
Yes,
also
exactly.
quite well known. And yeah, again, GPS is something which wouldn't exist because without space tech. All of the, I mean, not most, but literally all of the positioning systems that we use nowadays depend on GPS, right? If I'm not mistaken.
Yes, right.
Yeah. And also, I think you had mentioned ballpoint pens previously, which is, I think, a somewhat common example, but that's also quite an unconventional application which happened because of space technology. So, I mean, I'll quickly discuss what I had in mind, which was basically we know about roadways, and like road safety is a primary concern in roadways because a lot of accidents happen, and especially in India where there is a lot of like problems with the safety standards of vehicles and things like that. And I'm feeling like, or I have a gut feeling like when spacecrafts become more common and as more and more aircrafts reach space, like what Virgin Galactic is doing. So when that happens, they will also have to solve the problem of building uh, more durable materials and cheaper materials. And I think this will trickle down into the vehicles that we use ourselves. And through that, even our general transportation would become quite safer. At least that's what my opinion is. So that's what I think like an unconventional application of space technology could be. So actually now I'll open this question up to the audience. And so basically what we have been talking about so far is what opportunities exist for space technology in India? How can someone learn space technology themselves? And finally, this is a question for you that what are some of the unconventional applications for technology? So I will start inviting some folk onto the stage right now. So Pranav, I know you're a very big fan of technology. Can you talk a little bit about that? And what do you think is a unconventional application of space technology, if you want to?
Hey, hi Akash and Madhavi and Pratik. Thanks for having me over here. Maybe I've been researching about space a bit ever since I was a child. But if we have to talk unconventional, I would say probably utilizing the cold nature, like for example space has very low temperatures, you might know. And if we consider applications like quantum computing or for example nuclear fusion, these applications require like a lot of cold conditions, like in I think nuclear fusion, you probably need to create a potential like a temperature difference of huge amounts. Like the plasma inside the stuff is like very hot, and outside we have some semiconductor based cooling kind of system. So if we implement this on a planet without atmosphere like moon,
Right,
like planet or satellite, or in the space itself, even if you consider quantum computing, in case of the Googles, for instance, we use a lot of semiconductor cooling or some like very good kind of refrigeration, which takes lots of power.
right,
And it turns out that like creating that kind of power and redirecting it into cooling and utilizing all that becomes very like economically less efficient thing on Earth. But maybe we could have like floating quantum computers in space somewhere. And since the outside temperature is very low, you could at least have something at our end to manage with.
right, right. Actually, wouldn't like expect any less of an answer from you. That was a really great answer because if I feel like if we have really good network connections between Earth and like if we solve the network problem and if we solve the battery problem, we could have like we could outsource all of the data production and all of the power production to somewhere outside of Earth, right?
Yeah, yeah, totally.
Yeah, and then we just transfer that to here, I guess. Madhavi, do you have any thoughts on that? Hello, Madhavi, are you there? Uh, Anyways, wait. Do you have any questions, Pranav, regarding to like, I mean, opportunities in space tech, or I mean, anything else, like how? I mean, you're obviously a self-learner, or do you have any tips for everyone else regarding self-learning, I guess?
Maybe not that much. Like as in questions, like I have many. Uh, those are mostly like brainstorming questions. Like for instance, I was thinking a few months back, like uh, instead of how we do logistics right now, we put things into aircraft travels, and like for in some regions for reaching A to B, you take like 12 hours or something. The second way we could do is put those like goods into a spacecraft, get it out of out of the atmosphere into the Leo orbit,
Right,
and then the Earth rotate itself, right? And
right,
the spacecraft would have its own momentum. So maybe if we get out of orbit and again jump into Earth, then that kind of logistics way could be a much timely thing to do, or maybe less costly kind of thing. So we could have spacecrafts like dolphins jumping out of the atmosphere and back into the Earth's atmosphere.
right.
And this could be the logistic system of the future, maybe, if that's like possible via physics.
Yeah, that's interesting. Also, I think though, like because Earth itself is rotating and because gravity is a force which is applied at like every point of time, I think any object within the orbit would still have an angular momentum on top of it, I guess, right? Because it would still be rotating within the Earth's orbit.
Yeah, I think it would have velocities and momentums in all kind of directions. That would be, that would have to be controlled by some retro boosters kind of thing.
Right, right. Retro boosters meaning basically, I guess, propulsion systems which would go against the Earth's rotation, I guess, right?
Yeah, kind of third law of physics, just
Right.
with energy. Yeah.
Yeah, that's quite interesting. Uh, Shramik, since you're here, do you have any unconventional application of your own for like space
And
technology?
I don't think there are any unconventional application of mine, but I do know a few. One of them is something that we use regularly, right? Cameras.
Right,
So don't get me wrong, cameras were born and bred on this earth itself, but the research that led to making like minimizing the size of the cameras, it was originally for space technology, and that is how it became smaller and smaller. Now we have it in the palm of our hands. So I think that's one. And
right,
the next is like once Starlink comes up, then I would say it would be faster internet as well.
right, right. Also, do you have any questions for Madhavi, I guess? Or Madhavi, do you have any comments on this? I think she was having a few internet connections. Not sure if she has joined right now.
Yeah.
Uh, Anyways, yeah, I
Yeah,
think we
hello.
can. Hello, yeah.
Yeah, I missed the discussion.
Uh,
Yeah, I
Hello.
mean, yeah, I mean, I don't really have questions. I would say maybe some brainstorming that we could do. I mean, it's more or less like if we consider regolith on moon, is it possible for us to um like obtain water with some exothermic reactions? Maybe it has manganese and calcium in it. Maybe make an hydroxide of it, and then just do the acid base reaction and get water out of it. It's something kind of something similar on that line. Is it possible for us to do that? I mean, that kind of things. I really don't have any questions, uh, if I'm being honest.
Right. Yeah, Madhavi, do you have any?
Yeah, so about that, it's currently in the research phase. What you said is exactly what's happening right now. They are actually trying to extract volatiles out of the lunar and Martian regolith. It's somewhat same to Earth's uh, soil. So yeah,
What was
only the
the
content of
term? What was the term you guys were using? Jegolith or regolith? I'm not.
regolith.
What does that mean?
Regolith. It basically means soil.
Okay.
Does not mean anything else.
Space soil.
Okay.
Yeah.
Sorry, Madhavi, please continue with your statement.
Yeah, that's it. That's what I was trying to say, that it is in research right now. The Artemis mission that's probably will launch by 2020 is going to the southern region of lunar, where the volatiles are in abundance as it's expected. We don't know it yet. Uh, Once it launches and lands over there, uh, we could probably know more about it. But yeah, that's the thing. That's in its research phase right now.
Right. And did you hear what Pranav was speaking about before this? Or I think that's when you were facing some network issues, I guess.
Yeah, I could not.
Yeah. So
I did not
basically,
hear anything.
okay. So Pranav was saying that we could use the extreme coldness of space and run perhaps like quantum computing or fusion reactors in space because they require extremely cold temperatures. So, I mean, that was one of the topics he brought up. And another thing which I found interesting was we could probably solve intercontinental transportation by building, I guess, cargo containers which escape the atmosphere. And then when Earth rotates into the position that we are aiming for, it will re-enter the atmosphere then. Kinda like a dolphin jumping outside of the earth and coming back is the analogy he gave. So what are your thoughts on that?
So regarding the first idea that he gave, I believe that the batteries would need uh, a lot of radiation protection, so that would be costly. uh, those batteries would wear out. So rather than using batteries, they use all the spacecrafts and space missions use the solar radiation.
Oh, right. So, I mean, could we outsource power production of Earth to outer space?
Again, that would be expensive, so they would rather use the uh, resources that are available outside of Earth than to increase the payload and increase the expenses.
Right, right. I think you misunderstood. What I'm trying to say by outsource power production on Earth is that instead of having power plants on inside of Earth itself, like we have coal plants or nuclear plants or hydro energy, instead we manufacture all of that power in outer space, for example, on an asteroid or
Yes,
on
so
our moon.
yes, so that's the vision Jeff Bezos has. He wants to uh, 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 outsource all the industries that we have on Earth that's producing the toxic uh, if fluids and stuff like that. He wants to move it to other planets, and yeah. So, but it's we are not really still advanced that much that we could colonize right now. We are yet to go to Mars and Moon as in a full crewed mission. So it would take time, but yeah, it will happen someday, I think.
Okay,
But that would
interesting.
be very expensive, shifting all the industries over there. And for that, also there are very I mean, I would say there are limitations to building or colonizing other planets. So yeah, on and all, it would be very expensive. So
Right. Anant, are you there?
Yeah, hi.
Hey,
Hi guys. So thanks for having me. So like the most unconventional thing that I could think of that are used in day-to-day life are basically the games that we play. So
mm,
the game engines are basically took an inspiration from the physics engines because we need to do a lot of simulation to actually have the maths correct and to simulate the space environment so that we can actually dock our spaceships on the space stations, the satellites are working fine and all. So we need to simulate those environments, and the physics engines that are used in space research are just brilliant, and we are definitely improving there. A lot of startups are again originating, and it is great to see that ISRO is backing those startups recently. And yes, so the game engines are, we are playing games, and these games are trying to get more and more realistic. So
right,
basically, what they're trying to do is have the actual physics in place in the game engines, so that they can actually simulate the environment that we live in.
right.
So that is really great. And another thing that I would like to add is, like Pranav said on the quantum computers. So yes, the main agenda behind having quantum computers in place is to simulate quantum physics, because right now the quantum physics is a whole new world that we haven't explored yet. And there is a great concept in there that is quantum entanglement,
mm,
uh, wherein basically if we crack that, we'll be able to surpass the need of speed of light, which is again a barrier that we have in terms of communication. Our communication speed is limited to the speed of light. So the quantum entanglement is a concept in quantum physics which basically provides a way of communicating uh, to far and far places at the same exact fraction of second. So that's really great.
Right. So, I think, I mean, I'm not the best person to explain this. I think someone in the audience might be knowing more about this, but quantum entanglement is basically if you find two quarks or it was some subatomic particle, then they will have
Yeah,
the same properties, and you can find two of these at the same time, basically. And if you
yeah.
separate
So
them across space and you modify one of them, then the other one will have the same exact
same
properties at the
property.
same time.
Yes. So if you have two quantas, one quanta on Earth and one quanta on Mars, you can just communicate with each other at the same time by
Wow.
changing the states of these quantas.
Oh, that's actually quite a amazing thing. I didn't know you were so knowledgeable about these technologies. So, something interesting you brought up about simulations. We actually talked about simulations on the last session of permissionless learning, where we were talking about AR and VR, and Pratik and Madhavi were also giving us some knowledge about how basically simulations are used in spacecrafts and to other things. So, I guess, yeah,
Yeah.
Pratik, do you have any
So
thoughts here? Oh,
yes.
sorry,
So
Anant.
simulations are, yeah. So simulations are like very important part because we can't just send a spaceship in space and assume it is going to dock properly on the space station.
Right, exactly.
And so we actually need to have that properly, all parts need to work properly, and we need to simulate it. So which is again a difficult challenge because simulating space is not very easy since we know very little about it.
Right.
I wanted to know, so like Anand said, I was actually going to ask the exact same question. The real problem is, so there are two stuff basically. What Pranav and Madhvi was talking about the colonization. I
Hmm.
hope Akash I'm audible loud enough.
Yes, yes, you are.
Yeah.
So Pranav and Madhvi were talking about the colonization under different planets, and in fact, we all are fantasized about that, and I think this billionaires are working on that. But then on the other hand, Anand said the very important stuff. Communication is limited up to the light speed, which is obvious. We cannot go the normal communication signal cannot go par the light speed basically.
Right.
If we say so, let's say I want to know if we are colonizing at any of the planet or any of the subplanet or moon in any moon of the any planet, uh, how efficiently communication will be done. So the real question is, let me ask it in a brief. From Earth to moon, I guess I am not sure how many seconds or minutes. I guess it's something 6 minutes or something. And from Earth to Mars, I think it's some 21 minutes. I'm not sure about the figures. It could be plus or more, but let's assume something around 15 minutes. Okay, for planet like Mars or some moon. Can someone quickly tell me the figure? I mean, how much time we take to reach to the Mars
I think
in terms of light speed?
I think it was 8 minutes. Madhavi, can you correct me if I'm wrong?
It is usually there's a delay of 11 minutes for Mars.
11.
For Moon,
Uh,
I'm not sure.
Acha. So now, see, when I'm sending, if I'm building an industry over there, or if I'm building anything on the other planet, even if, let's say, I'm not building anything, but one of my person is over there on the planet. If I want to send something to him and then I get and want to know a reply from his side, ideally I'm taking 22 minutes. So how are we solving this communication problem? Because we are not just sending, we won't be the human being who will be just sending some message, but we will be actually sending the information, the transaction of certain process, the transaction of certain machine processes basically through that message, and not just the communication between two person. So how we solve this? That's the first question. And then second question is, I'm not sure who can be answer this, but uh, where are Richard Branson, Jeff Bezos, and Elon Musk are heading towards? I mean, apart from the Starlink, apart from some kind of a colonization, what is the big vision that they have in their mind? So these are my two questions: the communication and the vision by these three top notch space tycoons.
Yes, so regarding the communication problem, I am not sure if they are working on it or not. I'm sure they would be working, but how and in what manner, I am not sure about. So I'm not the person who could. I mean, I do not have any substantial information to share. But what was the second part of the first question that you asked?
So
Yeah,
if
so yeah, so
light speed,
yes, so
uh,
what happens is the communication gap. I mean, as somebody mentioned that the limitation is because of that we cannot reach beyond the speed of light, but it is also due to the
yeah,
rotational I mean physics and the rotational physics of earth and moon and the planet. They rotate, and we also have a blind spot that so an aircraft, a spacecraft, or a person who's on the planet can go into that blind spot for ranging from some minutes to maybe days. So that's also a limitation. We cannot, uh, uh, we cannot repair it, or we cannot. I'm not getting the proper word, but we cannot solve it, right?
understood.
So
But I have a question. So physically, it takes time to go and reach some place. That is okay. But once something is reached on the other side, I think the communication could be done faster. So how do we pass this barrier of, let's say Mars again? Minimum 20 minutes is not going anywhere. Minimum 22 minutes back and forth. So how do we solve to cross this barrier, or like what things are considered in the process? Like there might be some assumption or something like that, if it's 22 minutes, that is okay, the process will be delayed by 22 minutes, but I think that's not the feasible solution.
So
This is something interesting.
yeah,
I do not have any information on it, but yeah, okay. Anant, you can go ahead.
yeah. So like even those 22 minutes are not consistent. So even building that infrastructure in place, having those a number of satellites to jump the connection from Earth to Mars is another challenge also, because we need to have that consistent a 20 minutes or 22 minutes delay. So because there are a lot of asteroids which are bouncing the signals here and there, the Earth is rotating, Mars is rotating, and even the orbits are different. So it is very difficult to have a consistent connection to any particular planet. So that the first challenge there is that we have is having those channels of communication solidified. So we need to build satellites that can orbit within Earth's orbit as well as in Mars orbit. So at least we can relay down the connections from Earth to Mars. And then bypassing speed of light is currently not in scope of at least humans and the research that we have till now. But yes, there are a lot of theories like I talked about quantum entanglement. So recently, also in past few years, we discovered gravitational waves, which is another great concept that can be not just for communication, but it can also help in sort of teleportation, but it can provide a medium of crossing through barriers and moving from one place to another faster.
Uh, Anand, can you give more detail into that? How can gravitational waves help? I didn't exactly understand that particular part.
Okay, so basically, what gravitational waves are, unlike the radio waves, electromagnetic waves that we use, the gravitational waves can stretch and shrink space itself. So if the distance between Earth and Sun is, let's say, it is about 149 million kilometers. So if the distance can be reduced to, let's say, 1 kilometer, you can travel uh, in a much less time or bigger distance, right?
Yeah,
So that again is a very difficult thing to answer right now, but that's what the application of gravitational waves is. Since we can shrink and stretch the space itself, we can travel anywhere and go anywhere in the universe, at least the
Yeah,
observable universe that
this
we
is
have.
this is fantastic. I think with combination to this, Pranav was mentioning something now. So with combination to what Anant was saying, would dolphin jump come into the picture? Because the like the theory where Earth is rotating, so the cargo in the space would stay at one point. Then once Earth rotates, cargo would jump back to the atmosphere. Okay, the same way, if cargo can reach at one point where this one planet will pass and the cargo will be reaching to the orbit of another planet, because they are also rotating in the orbit, not rotating by themselves. So would that also be the case? I'm not sure about the orbital movement of both Mars and Earth, but I think dolphin jump could be. I mean, I'm not sure what I'm saying is right.
right. I think instead of moving through time, I mean, sorry, moving through space, they move through time or something like that. I'm not able to explain it, but
Ah, like
something.
that, the interaction of orbital rounds, the object can reach over there, which might the closest intersection point, and once Mars is coming to that point, that orbital range, this cargo, this bogie, this space shuttle can jump down to the Mars atmosphere.
It won't be that easy, I guess. We to get into the proper trajectory, there needs to be a lot of fuel use. So if we, uh, you know, of course, if we could make it more economical, more cheaper, uh, we could do it, but then it would take the time it usually takes. So 6 months, it takes around 6 months to reach Mars. So that does not happen straight away. The planets do not stay in the at one place. They are moving. So if I shoot my rocket from here, it won't go into a straight path. It has to be circular. So
Yeah,
the
right.
trajectory isn't linear. It's kind of angular. It is angular, I mean. So not very easy as it seems.
Yeah, it's not easy, I agree. Right. But I was just thinking of, how this communication, this range bound can reduce down. So I'm really curious and amazed to know what will bring in the future. But it's a big challenge, I think. The communication is a big challenge. 22 minutes is not feasible.
And
Well, there's
the
one thing.
technology we have right now, I mean, the all the spacecrafts, they move at a supersonic speed. So uh, it's a lot. They gain a supersonic and a hypersonic speed. So it's a lot actually, and the distance between planets is also a lot to bypass. So yeah, we do not have that advancement yet to just go linearly into some other planet.
Yeah, Pranav, you were trying to say something.
Yeah, so there's one thing we can do. So I think we have discussed like passing the speed of light. Like I don't know if that's possible. So probably like problem Pratik mentioned, maybe passing the speed of light isn't a problem of ours. Like maybe that's not the problem. What we could rather do is to bring down the communication is have self-sustained humans on Mars instead. So like something, a society which doesn't require to communicate on Earth in the first place. So I think that would be a cheaper solution. And how would we do that is probably having machines on Mars first. Machines would be able to compute great number of things, probably calculations and stuff, physics and everything, and maybe we won't require to communicate with Earth much, and will only require to communicate if there's SOS or something like that.
Yeah, that's an interesting point. Also, Madhavi, do you want to talk about? So, Pranav was saying before about, I mean, you might have heard it multiple times now, the cargo movement technology. So, do you think that would be feasible, like right now, or would it require some technological changes?
Technology wise, I guess it is possible to have such a mission, but then again, money comes into matter. Like, why do you want to move the cargo if it's I mean, if through an aircraft or through the ground itself you can solve the matter, why do you want to use a rocket to transport the cargo? That's the
One
question.
point would be, would it be faster to do so via the rocket?
Yes, it would be much faster,
Okay,
but
yeah,
it
I guess,
would take a lot of money to build the infrastructure,
right. We could.
because the launching and the landing is uh, it's not predictable. So
I think there's one another analogy to that. Imagine Virgin Galactic VSS Unity. They are having people in there, like just replace that with cargo. But the difference is that they are doing it with two plane system. Like it's not a rocket based system. I think the most difficult part would be designing the rocket itself, because like it's re-entering and entering at like multiple times, and SSTOs, like single stage to orbit. So right now, if you have seen ISRO rockets, they have like multiple stages. They have like two extra boosters. In all, ISRO has like five stages. For instance, SpaceX has like at most three stages. They get into the orbit in three stages, and then there's a concept of having single stage to orbit. That's the most difficult one. And if we have to, do entering and re-entering like very frequent times, maybe that SSTO thing is worth a research.
Right. So I think Madhavi got disconnected, but I'm curious, and I think Pratik and Anand would be too. What's SSTO? I mean, I think the process you just described must be SSTO. So what's the full form of it? Single stage something something, I guess.
Yeah, single stage to orbit.
Oh, okay. Single stage. Got it. Madhavi, yeah, do you have any? Do you want to say something?
Can Pranav repeat what he said?
Yep. So we were discussing like how, like if we are like delivering cargo like that, it would take multiple re-entering and entering points into the atmosphere. So probably having a much simpler, like if you're talking about costing and stuff, then having a much simpler rocket or a space vehicle would be beneficial. And if we talk about rockets right now, I think that they are okay, cheaper, but like they are still
Yeah.
in
So
terms of
about
probably Asian
SSTOs,
countries
they
much.
can. Okay, sorry to interrupt you, but SSTOs can they have a very less payload capability. So it would not accommodate the price at which it is built. And why use rockets? We can also use aircrafts. Uh, the commercial uh, altitude at which the altitude at which the commercial planes fly is I'm not sure, but it's around 10 to 12 kilometers, I think. So they usually fly on that line, on that altitude, but they have a capacity to go much beyond. I mean, they can go higher up. So we can rather use planes to transport the cargo instead of building a rocket.
Yeah, I think it's fair to do both. I think Pranav was just ideating how we could do it.
Yes, right.
So yeah, I think I mean, the realistic factors are definitely there, but it would be, I guess, interesting if something like this was really possible. So generally, I think I mean, I know it's like we are beyond our 1 hour time limit, but I generally do a final round of like what everyone has been learning over the past 2 weeks. So
Before Akash, before you go ahead, just a last question. It was unanswered, so I wanted to ask any one of you guys, where are these three space tycoons are moving towards? I mean, what is a vision or what is a hidden objective? What is a long-term objective that these guys are having? I wanted to know that. Richard Branson, Elon Musk, and Jeff Bezos.
Pranav, I think you would know because you're tapped into the modern internet ecosystem.
Yeah, so I have a perspective on this. So I think many people think that they are doing just one thing, because mostly in our perspective, space is one thing right now. So whoever is going to space, they must be doing one thing. But like going deeper into that, if we talk about Richard Branson, he is like bringing tourism to space. So that's like a Earth centric thing right now, I think. And it's like opening up space to humans, uh, and like maybe space and a bit of like outside space to moon or something. So like Richard Branson's focused at space tourism kind of thing. Maybe it could go into becoming hotels on moons and something in future. If we talk about Jeff Bezos, I think more than colonizing planet, Bezos is interested in having humans live in empty space. So, like if you have heard of O'Neill cylinders and stuff, so Bezos is inclined to that. So O'Neill cylinder is a spacecraft which is like very huge, and wherein humans can live like for longer durations and have all kinds of comfort and things. And if you think Elon Musk, he's like into planets. Let's colonize another planet and live over there. If you see Jeff Bezos, he's like, I don't know about planets. Let's do it in interstellar space itself. Why colonize the planet?
Okay, got it. Thanks. But any idea what are their commercial objectives? especially
Interesting
Richard
idea,
Branson, the
Pranav. So,
commercial objective could be sorry Madhvi. For Richard Branson, the commercials could be explanatory, but I'm curious what are planning by Jeff Bezos and Elon Musk.
I think it starts with trade, like what space is abundant with is resources. Like you have all kind of materials and stuff. So if Elon Musk is doing it on Mars, he will have first Martian resources. Second, he will have a huge leverage on human resource because Mars, like colonizing Mars, will require a lot of humans, and probably he would be like on the forefront of having very powerful human resources around the planet or something, and would be able to like do anything regarding to space and stuff. For Jeff Bezos, I think it's a lot related to mining and stuff. So if we talk about space, how the money is flowing, most of the money in the starting, I think, would be flowing via mining and stuff. So, like, if you consider an analogy, like when Europe started colonizing all other continents, what was the main source of income? It was mostly trade. So, same thing I think will happen here in case of Elon Musk and Jeff Bezos. It would be trade of some kind. Another trade thing you could do is you could manufacture things on moons or in space and then send it back to Earth.
Right. Also, I think something
Cool.
that Madhavi had told me about previously was we could also have infinite machines. I think this is a concept which Elon Musk kind of made famous, where you build machines on Mars which use all of the abundant iron and oxygen, sorry, all of the abundant iron on Mars to build more machines, and then all of the, I mean, since I think when iron is converted or rust is converted into iron, oxygen is released. So they will also at the same time oxygenate the surface of Mars. So that infinite machine thing is quite interesting, but I don't think perpetual machines exist yet. So that wouldn't be possible, I think. Uh,
There's another analogy. For instance, if you see Venus has like abundance of CO2. Like it's like probably a CO2 enough to have like Mars turned into a greenhouse planet.
oh, okay.
So there's this kind of thing. Mars on one side doesn't have atmosphere at all. It requires CO2. Then there's Venus, which has like abundance of CO2, and we need to remove it. So
Right.
in future, if ever anyone tries to, get like use chemical processes and remove CO2 from Venus, they will probably trade it to people who are living on Mars.
Oh, yeah. Also, like, I mean, a natural way to do it, like the best machines are basically living things. So even Earth used to have a lot of CO2 in its atmosphere a few million or billion years ago. I'm not really aware of the timeline. But then phytoplanktons converted all of the CO2 in the air to oxygen, and that was actually called the Great Oxygenation Event because the Earth's CO2 levels dropped from something like 90% to 20% within a few million years, which isn't really possible without living things actually like actively converting that. So we could probably introduce phytoplanktons into Venus or Mars's atmosphere, I guess.
Yeah,
So,
yeah,
yeah, Venus is actually like considered to be the most closest planet to Earth in terms of having a habitable environment, because uh, if you were to erupt all the volcanoes on Earth, you'll basically have Venus.
Oh,
So,
interesting.
and given that we recently also, like a few years ago, we find traces of bacteria in the atmosphere of Venus. So that basically like gives us insight to how Venus could was like before all the volcanoes on Venus were erupted. So yeah,
Damn,
basically like Venus is very close to Earth.
that's some like alien level shit. Like
Yeah,
civilization already existed, but then volcanoes got erupted, and then some spacecraft
yeah.
landed on old Earth, which kind of which is why humans exist.
There are like
No,
a lot of
but
theories there,
I
but yeah.
I found Akash idea very the alien shit idea was Akash idea basically implant the living things into some planet and finish off the CO2.
Yeah. Uh, yeah, Pranav, Madhavi, do you have any thoughts on this?
About the phytoplankton, like that's a good idea. We could literally do that. But on another side, it would be like living on a time bomb, you know. So what you're doing is artificially converting rocks. So on Earth, if you like compress CO2, you can call it rocks of some kind. So like in like longer carbon cycle, CO2 gets converted to rocks and stays inside. If we do the same with Venus, yeah, we could do that. Maybe we will have huge ice sheets of CO2 spread all across Venus, but on the same time, it will be a time bomb. One day, like something just drastically chain reaction could happen, and that all CO2 could re-release itself.
Right, or we reintroduce evolution to another planet and we introduce a competing species there. I mean, that's over a scale of several millions of years, but still.
Yeah, yeah, that's actually next level Jurassic Park thing, gene editing and stuff.
Anyways, yeah, I think,
What
sorry, yeah,
Pranav
Madhavi.
explained was the composition of a basalt rock that got decomposed several years ago, and yeah, so it's basically that CO2 decaying into becoming a rock.
Oh, wow, that's interesting. I didn't know that. So yeah, I mean, I think we can go into the learnings kind of section. Like, what have you guys been learning this week? So Pranav and Anand, you guys are kind of joining us for the first time. So Pranav, do you want to talk about what you had been learning over the past 2 weeks and what you found interesting in it?
Past 2 weeks I've been mostly doing sales, so there's lots of learning over there. So I've been helping a company, mostly a startup, get the product in like PMF phase. So there's some learning in there, like what the product should be like and all the expectations, like how to find first customers and stuff. So that's the majority part. Uh, like the second part is mostly chess. I've been playing chess a lot.
Oh wow, that's interesting. So Pratik, do you have any questions for Pranav? Since I mean, so Pranav basically Pratik is also working on his own product, and he has a lot of thoughts on that, and he has also been learning new things like Figma to help himself grow and build that product. So yeah, Pratik, do you have any sales side
Great.
questions?
Not as of now, but we can connect later. So Pranav, basically I'm working on the AR and VR product for the fashion industry. And I am particularly not into software, but I'm trying to build a team and the existing my partners, my existing colleagues. I won't call a partner, the colleagues. They're also into trying to basically build this product. So we have the product idea is technologically not yet sound. It's not there yet in the market, and it's the most challenging because if you see the life of AR VR specialist on the earth, basically just 2 years. So the product idea that I have, it's still in the very toddler stage.
Yep, yep. Yeah, let's stay in touch like anytime.
Yeah, yeah.
Yeah, Anant, what have you been learning for the past 2 weeks? And anything
Oh,
interesting
well,
you want to share from it?
so like I've been doing a lot of research on astrophysics as like I'm very interested in there. So there are a lot of theories that I have explored, and like the biggest thing in space, like the biggest resource in space is dark energy,
Hmm.
and but we don't know how it is there and how it got there, how it is released or how it is made. So my theory on that is like everything dies, right?
Hmm.
So even our protons, the basic elements, the particles that we have, they are like expected to decay or decompose in of sorts in about 10 to the power 28 years. and so it is again possible that dark matter might have decomposed to build our basic particles that we have right now. So again, this is a very long shot, and so because basically the dark matter in the entire universe is contains more than 95% the dark matter and the dark energy, and the matter is only like 5 to 4%, and the matter is constantly growing in terms of, but then again it is very because the observable universe that we have is again growing, because we have not the light that we have captured till now is only 14 point some billion years old.
Right.
So like my theory is basically that dark matter decomposes or basically has fission in there, and it creates these particles that we have like quarks and electrons and neutrinos and all. But yeah, so apart from this, like it's mostly have been work and a little bit of gaming.
Ah,
So I'm just like planning out the products that we are going to build for the company, and the few versions how we are going to roll out these product for our customers and all.
okay. Nice. So something you were talking about in regards to databases was also materialized view previously, I guess.
Yeah,
I mean,
so like you want me to talk about it?
I think you could
Okay.
give a, can you talk about it in a sentence?
Yeah, sure. So right now at the company where I'm working, the database that we are basically in terms of the database that we use and how the data is structured right now, it is very difficult to get the correct data output. And because in terms of time for customers, the analysis and the insight should come faster. So what we have done is, what we have researched on is, we can transform our tables, or at least get the data from our tables into a facility provided in databases that termed as materialized views. So materialized views are basically a replica of tables. You can do everything like indexing and constraints and all that we have, and optimize the workload and optimize our database to do better read only operations on our database and get the data faster.
Right. So basically, if you have a bunch of really bad data, you write some queries which run every few minutes or seconds, which create these tables, and then you query these better structured tables instead, so you get better read outputs, I guess. Right?
Yeah, yeah, yes.
Cool. So about the dark matter part, Madhavi and Pranav, do you have any of your own comments on this?
I don't know much on that side. Probably still looking at stuff.
Ah, right. Madhavi, are you there?
Yeah, same with me. Haven't read much about dark matter to uh, discuss it with Anand.
Oh, okay. No problem. So, yeah, Pratik.
Yeah, no, I was just going to say that we I would also discuss with Anand once about the dark matter, because yes, I'm interested in that topic, but haven't read much about it.
Yeah, like what have you been learning over the past 2 weeks?
So past this week, so I got vaccinated, so I was down entire week.
Ah, damn.
So,
Yeah,
so and then next week, I mean the last week, I was just recovering all the left out of the previous week. So nothing much this time due
ah,
to
okay.
vaccination.
Oh, yeah. So it was your first shot, I guess.
Yeah, it was for sure.
Nice, nice. That's good.
So apart from this, I'm recollecting the different parts to build out my ideas along with my partners. So that is obviously ongoing thing.
Okay. So anything you want to talk about from within that, or is that all hush hush?
Is that all, I guess, from my side? Because I don't have any concrete information yet to share from my side on that AR/VR product.
Got it. No problem. So, over the past 2 weeks, I think you guys might already be seeing I'm focusing even more on content. So I was creating the React 18 video, which took a long time for me. And in this week, I was trying to do promotion for this Clubhouse event that we are currently a part of. And also, I was actually converting my video into an article format so I could publish it on Free Code Camp and get even more promotion from there. And I think I could talk about uh like I could talk about React obviously, but I could also talk about my content schedule and how I'm scheduling all of that if anyone's interested, I guess. But yeah. Yeah, Madhavi, do you want to talk about what you've been doing over the past weeks, learning over the past weeks?
Yes, so I was reading about this technology called as moon fiber. So the lunar soil is very similar to the soil that we have on Earth, basically basalt rock. So uh, the Aachen University, people at Aachen University had uh, this idea that maybe we could use those basalt rocks and turn them into basalt fibers that could be eventually used as composites, maybe for construction purposes when we colonize the moon, or maybe as insulating materials. So that was something I learned. I'm
Okay,
still learning on that. What advancements they have made till now and what are the limitations. So yeah,
that's
that's it.
actually quite interesting because it goes into, obviously the part where, that's a different topic, but basically composite sounds interesting to me because if we can we can remove raw construction material from like things which are quite readily available on a lunar surface, then that means that we could build those things quite faster and quite cheaply, I guess. And also the fact that we can use the moon's own surface to build materials on moon again, then that means that we don't have to transport anything from here. So that's also interesting. I think that also goes into the colonizer kind of analogy because that's what the colonists also did. I think they used the local soil and the local spices and fruits and then traded them to get richer and richer, I guess.
Yeah.
Yeah, Pranav, do you have any thoughts on that? Or Madhavi, even you? Uh,
That's an interesting theory, actually. If we are to become multimillionaires, or for that matter, everybody of us, if we want to be on the richer side, we could just mine a single asteroid and we could use those resources over here. And yeah, so that's the thing.
yeah,
It's called as in situ resource utilization, utilizing the resources that we have over there rather than transporting it from Earth.
cool. That's a quite an interesting point.
It's kind of already in works. Like there are some people doing it, building space factories and stuff.
Have the actual steps been taken?
Yeah, so there's a an investor from Peter Thiel's
Yeah, I know.
uh, VC company. So he's itself doing it, and like he's backed by uh, all investors, good investors. So I think it's pretty much in motion. And apart from this, there's another company who is manufacturing solar cells and semiconductors in space. So they have set up and everything done.
Oh, okay.
Another thing is actually ISS did that one itself. So they launched a facility to be integrated with ISS, and it was a semiconductor manufacturing rig of some kind. So they attached it to ISS and rotated it centrifugally to test if we could make semiconductors in space.
Oh, that's crazy. So what was the result of that?
I don't know much of the details. I think it's in research still. Like they haven't commercially done it, but they have researched. Like even if you talk about building composites and stuff, so we talked about difference between, if we talk about difference between mining or building things on moon and earth, the biggest difference is gravity. So there's gravity on earth, there's much less on moon. So the result is that on earth you'll require this use cranes and all that stuff to manufacture or set up a factory. On moon you might not require that.
Right,
Or in or in space where there's microgravity, you don't require any kind of cranes or things to hold stuff.
Yes,
So
so
if
to add on it, there's little gravity, so a lot of the soil is porous, right? So a little impact and it just blows into the air. So it's very easier to catch it rather than mine. So
yeah,
that's the mechanism used.
Yeah, so if we talk about composites, same thing happens. So composites is a mixture of two different things, right? So if you have to create an alloy, you will probably mix two things. Now, if you do it on Earth, gravity applies, and there's all this sedimentation and all that kind of stuff. But if you do it in microgravity, if you put something into a material, it might just homogeneously mix up itself without sedimentation or stuff, and that would give a more equally strong material and that kind of thing. So that's exactly what they are trying to do with semiconductors. They are seeing if they dope semiconductors, like if they are doing doping for manufacturing them, if they do in micro G, will they have much better quality semiconductors?
right. I
That's a
mean,
really interesting thought. I
yeah,
liked it.
whether we can improve the quality of our manufacturing processes by doing them in space. And that's like 3D, that's like playing 3D chess basically. Uh, yeah, anyways, I think we're hitting the 1 hour 30 minutes mark right now. So it was a good session that we had today. Thanks Madhavi for being a part of it, and sorry I grilled you so much. I know I grilled the speaker a lot. Like I think even Pratik felt that I grilled him a lot previously. But I think that makes for a more fun session, and that everyone gets a chance to learn about every facet and get to know about what you guys also internally know. So, thanks, guys, and I guess let's see each other in 2 weeks. And you all can also connect with each other on a more personal level, I guess. I think you're all connected to me, so you can ping me and I'll message you each other's numbers if needed. So, all right, guys, bye bye.
Thanks
Right.
everyone. See ya. Bye
It
bye. Have a
was
nice
nice
weekend.
talking to you all. Bye bye.
Yeah, bye
Yeah.
guys.
Yeah.
Bye.
Bye. Guys.